Hey class, hopefully everyone is doing quite well. Here is our video for our central fatigue lab. So this lab is very similar to past ones that we've done, however it will be a little bit different. So let's go ahead and get into that. What you're going to turn in a short video of either yourself or a friend performing this lab, at least the numerous different aspects of the lab, or a multitude of pictures proving to me that you actually did do every aspect of this lab. There is a worksheet at the end after the background, the procedures, all of those types of things that always shows up at the end of these documents. Really, there's not very much to this. There's only two things that you're going to be doing. You're going to be doing them at two different time points, and that's really about it. The biggest thing to do with this lab is that you're going to write a paper about it. So a paper about the origins of fatigue and how it might differ between whenever we're doing like high intensity exercise or lower intensity exercise that has a long duration. So let's go and look at a few of these things. I attached or included within here a lot of things that I do think that you ought to read or that you should check out. So this right here, background, just what fatigue is. This is the introduction from this paper right here, Muscle Fatigue, General Understanding and Treatment. So overall, what that paper is actually doing, go look it up. It's really interesting for ways of treating it. There's even this section on like drinking Red Bulls. So, not to give too much of it away, of course, I wouldn't be testing you on any of it. I just think it's really interesting for you to check out. But they're trying to explain in a pretty easy to comprehend way what fatigue is. So fatigue generally, just tiredness, all of these different types of things. And one of the ideas that always has eluded many physiologists and has been interesting to myself and many others is why do we even get tired? So why can't we sprint marathons, my one repetition max, why can't I just do it a second time? Why is it that it's only one rep and that's all I can do? So with this, there broadly are these two different ideas that maybe some types of exercise it's more one, other types of exercise it's more the other. I want you to be investigating those types of things for the paper that you're going to write. But there's central fatigue and there's peripheral fatigue. So just very generally what that means, and like I highlighted a few of these things. So central fatigue, that's really just anything that originates within your central nervous system, so brain and spinal column. So that could be your premotor cortex, your motor cortex, your cerebellum, all of these different things. A lot of it seems to have to do with signaling of like norepinephrine, dopamine, 5-HT, or like serotonin, right? Um, a lot of different like neurotransmitters and drive from the central nervous system out to your periphery or your musculature or whatever. And peripheral fatigue, which is a little bit different, meaning that it's distal or below, like our kind of how this paper writes it, it's below our neuromuscular junction. However, some other authors think that it's just anything that's not within your brain or spinal column. So that could be things like, the innervation of like a particular motor unit, the acetylcholine making your muscles contract and all of that type of stuff. Or it could be actually just within the muscle, so like glycogen depletion and accumulation of hydrogen ions and accumulation of phosphates, reactive oxygen species, all kinds of things like that. So check all of that out. Please do a lot of thorough reading to try to understand that as best as you possibly can. And like ask questions if anything doesn't make sense. Or if you come across any papers that you think are bogus, send them my way. Like I'll check them out. I'll try to help you decipher if it is or is not bogus. So there's that. A little bit of a little bit of an explanation that you can read just with that there. Now, this is a little schematic that I like to give out to people. So this one has a study from 1961. This other one is more of a review article from 2010, comparing and contrasting like central and peripheral fatigue. So peripheral fatigue, kind of like what I was saying, like hydrogen ions, phosphates, those seem to be the main things that a lot of people are thinking these days, being the cause of muscle fatigue just generally. There could also be like lack of oxygen, lack of blood flow, occlusion, those different types of things. Now on this other end over here, I always love pointing out this study that was done because it was a pretty amazing study. So they took a bunch of individuals, had them do that MVC, that stands for maximal voluntary contraction. So they did effectively an elbow flexion, a curl, against something measuring how much force they were generating. And they did it every couple of minutes or so. And interesting thing that they would do is they would fire a gun at them. And anytime that the gun was fired at them, they had greater, central drive from, their central nervous system. And then, as they're diminishing, getting easier or somewhat adapting to the gunshot sound, then they had a very large man yell at them. And, that's kind of indicating that, motivation, norepinephrine, these types of things might have quite a bit to do with fatigue, at least in this realm of like intensity or contraction or whatever. So then here, let's go and get into a few things that we're actually going to be testing in this lab today. So here is one of the ideas that I have. We're really only going to be testing central fatigue. So basically, you're going to be doing two different types of isometric muscle contractions, just time to fatigue, endurance type of stuff. But you're going to be doing it with a small muscle group and a large muscle group. So the large muscle group that you're going to be using is going to be, your hips and legs. So this little like brain homunculus type of thing that this is kind of the amount of cortical space given to all of these different aspects of our body. So here, the hip and leg, it's not nearly as much as our hand and fingers, right? So we're going to be testing fatigue and central fatigue, cortical meaning, cortex brain, how much it's impacting our control over these different areas of our body. So we're going to be comparing the leg and hip to effectively the hand and the fingers in many ways, right? So here are the procedures that you're going to be doing. You can read through that, but I think that this is going to more or less tell you exactly what I want you to do. So how we're actually inducing central fatigue is one time you're going to do this with your eyes open, the other time with your eyes closed. So the idea is that we typically have more excitation in our brain whenever eyes are open. So if your eyes are closed, then we're actually getting less of like a neural output from the central nervous system, thereby somewhat inducing like central fatigue or decreasing central drive, more or less. So the idea is that maybe potentially that if you close your eyes, maybe you won't be able to perform as well as whenever your eyes are open. So test it. We'll see if that actually happens. This is the real world. This is science. So I actually want you to try very hard and see what occurs there. So with this, one time you're going to be doing a pinch grip. Find something to hold on to that you can't just hold on to all day. Not like a pencil or something. Maybe a couple of books. Stack them together and have both hands. Since I want you to use both your right and left hand to hold this, not have one book in one hand, another book in another hand. I want them to be more or less working together, kind of like in this picture. Warm up beforehand, of course. See how long you can last holding that until you have to drop it, then hit the stopwatch. Warm up in like at least 6 hours later, then you can do your lower body one. So here, eyes open, of course, lower body wall sit, 90 degrees with um, uh, the ground, so parallel with the ground, of course, like 90 degrees in the knees. I'm sorry, talking a little fast right here. Parallel with the ground, legs should be burning, eyes open, see how long you can last there. Um, Day two, at least 48 hours after day one. I don't want anybody getting sore. You really shouldn't get sore from isometric contractions, but just in case you have any soreness. Then flip it. Eyes open here, eyes closed there. Um, Hopefully, all of that makes sense. What somewhat came to uh, my idea with this was actually from this particular study right here, muscle mass and peripheral fatigue, a potential role for afferent feedback. This study was actually really interesting. Not very many people in it, only 8 males, but they were trying to look at the differences in peripheral fatigue. So if you're using a lot of muscles versus less muscles, is there a difference in peripheral fatigue or overall kind of what's going on up, sending like afferent feedback to the brain? And well, they actually did find some pretty interesting stuff. So the CNS tolerates a greater magnitude of peripheral fatigue whenever less muscle mass is actually utilized, and allowing for a greater intramuscular metabolic disturbance. So if you're ever working with somebody who is somewhat of a endurance athlete doing, like like large muscle movements, so like running, cycling, all of those different types of things, they're using a lot of muscle mass. And the idea from this study is at least that since all of those different muscles are sending like afferent signals back to the brain, you're going to fatigue sooner than is enough time to accumulate like all of the work in the particular muscles. So it argues for maybe at least sometimes working smaller muscles so that you can accumulate a lot more stress just in those singular muscles. At least that's partially what's going on. I mean, like they did a lot of cool stuff. You can check out the study and read it if you so wish. I think you should because they do a super maximal magnetic femoral nerve stimulation. So very interesting stuff. So um, uh, basically, in a way, kind of shocking their nerve to contract 100%. But that's neither here nor there because they were really just looking at peripheral fatigue, but what you're looking at is really more central fatigue. So again, that's what I want you to be doing with this. So read this. I could explain it again if you want, or contact me if you're having any problems. But that's really the crux of this lab, and this is what you're going to be filling out. Not a lot in here again. So weight hold seconds, eyes open, eyes closed, wall sit seconds, eyes open, eyes closed, compare it, and insert a line graph with the condition on the x-axis, so that means these eyes open, eyes closed, that's the condition. And then the eyes open, eyes closed condition on the x-axis. I could have said y-axis a second ago, and I did not mean that. Now the y-axis, that's going to be our time in seconds, and this could go into hundreds of seconds if you're really good at wall sits or you found a light weight for you to hold. So then answering this question, but here, right here, here's the big part. Write in the paper. I've alluded to it already. Just a few more aspects about this. It needs to be at least 2 pages double spaced. There's no limit on how many pages it can be because fatigue is a really interesting thing. Utilize Google Scholar. Include a references section. really what you want to be doing in this is explain what fatigue is, some of the studies, how we know about central fatigue, peripheral fatigue, and how maybe they differ in the types of exercise intensities that we're actually doing. So hopefully, you've used Google Scholar before. There it is. Use in-text citations. Never use quotations, always paraphrase. Here's an example of an in-text citation. If you've never seen one, here's an example of what your references section needs to look like if you've never seen that. Um, Overall, just APA style, double spaced. Those are the main things that I want out of you with this. And here is just a general guideline for writing papers, and I think this would be good in any class ever, but write it for an intelligent person, but that person isn't in this class. So um, try to explain jargony terms down to where, you could explain it to, you know, your mother, father, brother, sister, whatever. But really, that's about it for this lab. Pretty straightforward lab, I hope. If it isn't, please contact me and let me know, and I will certainly try to help you out much, much more. All right, good luck. I'm going to give you quite a bit of time to work through this one. All right, thank you. Bye.